So, it seems like you're really interested in LLMs, large language models, especially how they handle complex reasoning. And well, we're going to take a deep dive today into a technical report on Xmodel-2. It's designed, for better reasoning and efficient training. The source material we're looking at today is a report from the Zhao AI lab. And what's cool is they've actually made Xmodel-2 and its code available on GitHub.
One of the really impressive things about Xmodel-2 is that it only has 1.2 billion parameters, but it still outperforms much larger models on complex reasoning benchmarks. You can really see that in Figure 1 in the report.
Yeah, the architecture itself is really interesting. They use tensor programs. I have to admit, that sounds kind of intimidating at first.
It's actually a pretty clever strategy for efficiency. Tensor programs let the researchers use the same hyperparameters across different model sizes, so they can experiment with different configurations on a smaller model, and then just apply those optimal settings to a larger model, so it really streamlines the whole process.
Oh, so it's like figuring out the best study techniques, but on a smaller subject, before you try to tackle a much larger one. So I'm curious about the training process. What makes it so effective and efficient?
Well, they have a two-stage training approach, stable training and then the decay stage. The first stage uses a massive data set, 1.5 trillion tokens, mainly from open source data sets. And then in the decay stage, they fine-tune the model with a mix of that data and high-quality supervised fine-tuning data, SFT data.
The report mentions this thing, data ratio optimization, in the decay stage. What exactly does that involve?
It wasn't just throwing any data at the model. They were really strategic about finding the best balance of data types. And one key finding was using data formatted as instructions, especially for math and code, really boosted Xmodel-2's reasoning abilities. It shows how important it is, how the information is presented to the model.
So it's not just about how much data, but also how that data is structured. I noticed they use a lot of different data sets in the report.
Yeah, for the stable training stage. They use data sets like FineWebEdu and Dolma, both large English text corpora. They also included some code-specific data sets, like StarCoder and the Stack. Then in the decay stage, they incorporated data sets that are known for high-quality instructional data, like EvilInstruct, OsInstruct, and UltraChat.
And I see they also created what they call an SFT mixed data set, which includes data across 5 categories: math, code, logic, knowledge, and common sense. It seems like they really wanted to cover a broad range of knowledge domains.
Yeah, and they went a step further. They went through this whole process
Yeah.
of deduplicating and diversifying the data to further refine it. And these small adjustments actually led to noticeable improvements in performance.
It's amazing how much attention to detail goes into creating these models. So let's move on to the results. Xmodel-2 seems to be a top performer when you compare it to other models of a similar size.
Absolutely. The report compares Xmodel-2 to similar models, and the results are pretty clear, particularly in Table 2, which focuses on tasks that require common sense reasoning, like ARC, BoolQ, HelloSwag, and Winogrand.
Those are tough tasks, even for humans. What about its performance on more complex reasoning tasks?
Table 3 shows it excels in those areas too. It scores very highly on benchmarks, like GSM-8K for math problem solving, math for mathematical reasoning, and even Human Eval, which tests its ability to generate functional code.
They also explored Xmodel-2's agent capabilities, which I think is really intriguing.
They wanted to see if the model could perform tasks in simulated environments using the React prompting technique.
What kind of tasks did they use to test those agent capabilities?
They chose tasks that would challenge the model in different ways, like there's Hotpot QA, which requires it to reason across multiple documents to answer questions, Fever for fact verification, and AlfWorld. That tests spatial reasoning and decision-making in a simulated environment. And then WebShop simulates online shopping tasks.
Sounds like those tasks are pretty complex. They require the model to go beyond just understanding language.
Yeah, for sure. It needs to be able to plan and interact and adjust to changes, all within these simulated environments.
And how well did Xmodel-2 handle all that?
The results are actually really promising, especially when you consider its smaller size. You can see in Table 4 it has these high success rates in tasks like Fever and WebShop, which suggests that it has real potential for handling complex real-world situations.
It seems like they put a lot of work into making this model powerful and efficient.
Well, that focus on efficiency is really important, especially as some language models are getting, increasingly large and resource-intensive. Xmodel-2 shows that you can actually achieve strong performance without needing a ton of computational power, which could make these models accessible to way more users.
The report also mentions Xmodel-2 as excellent calibration.
Right. So that means It's good at knowing how confident it is in its predictions. So it's not just trying to get the answer right. It also understands how likely it is to be correct. And you can actually see this visually in Figure 4, how the predicted confidence aligns with its actual accuracy.
That's really interesting. The researchers also explored what they call post-training scaling law.
Oh yeah, that basically means that giving the model more context as input can lead to better prediction accuracy. So if you look at Figure 5, as the number of prompt tokens increases, the model's perplexity decreases. Perplexity is a way to measure how well it predicts the next token in a sequence.
So the more information it has, the better its predictions become.
Exactly, but there is a point where the gains you get from adding more context start to diminish, like they become less significant.
So this whole deep dive into Xmodel-2 has been really informative. We've covered its unique architecture, the efficient training process, and its impressive performance on all these reasoning tasks, especially those agent capabilities.
It's a big step forward in language modeling. It'll be interesting to see how it influences the future of AI.
Yeah, it really highlights how AI is becoming more capable of reasoning like a human in these complex scenarios. And the fact that it can do all this, while being relatively small and efficient, opens up a lot of possibilities for different applications, potentially even leading to more accessible and sustainable AI solutions. That focus on being smaller and more efficient, it has a lot of practical advantages.
Definitely. Smaller models need less computational power, which makes them more accessible, especially for researchers and developers who might not have a ton of resources. It could lead to more innovation and a wider range of applications across different fields.
And the impact on mobile devices could be huge. Imagine having this AI assistant on your phone that can understand complex commands and even work offline.
Yeah, that's becoming more and more feasible with all these advances. In model compression and optimization techniques, not to mention more efficient hardware, it's getting easier to run these sophisticated AI models on devices like phones.
And the fact that it does so well on tasks designed to test common sense reasoning suggests that these models are getting better at understanding the nuances of human language.
Yeah, common sense reasoning has always been tough for AI because it needs a lot of general knowledge and the ability to apply that knowledge flexibly. But Xmodel-2's accuracy on tasks like Heliswag and Winagrande shows real progress in this area.
So this whole deep dive into Xmodel-2, it's been really fascinating. We've learned about its innovative architecture, the efficient training process, and its strong performance across a range of tasks, including those agent capabilities.
It's definitely a big development in the field of language modeling, and it'll be really interesting to see how it influences the future of AI.
Well, it sounds like we've both learned a lot today about Xmodel-2 and the future of reasoning-focused AI. Hopefully this deep dive has given you a lot to think about as you continue to explore this really exciting field.